recorded. It's relevant. It's Thursday, February 19th. You guys got these chapter 13 fluids puzzles. You maybe to read these. They're very complicated, so you guys have these. So we have you guys solve these in class today. So just solve any 7 and turn it tomorrow. You guys know, of course, there's a quiz tomorrow, so you can use these to study. You guys know the more you solve, the better you're going to learn this. Okay. And here, I'll give you guys a brief overview, the basic formulas that you need to solve these. Right, so I went through question by question. So what category question is this? Okay, here's how to solve every single one of these. Well, like the big picture idea, right? So it's like some basic formula, like what's Bernoulli, what's Archimedes, what's Pascal, right? So and then I went back and I color coded it. So like anything green, you guys see all these green right here? That's related to either some version of Pascal's principle, or you guys know pressure is force per unit area. Or guys, could you rearrange this and get force equal to pressure times area? Could you do that too? Yeah. Right. And then notice that some of these I put a little delta. Guys, what do you think? Here, how about this? Guys, what if there's a window? Can you guys imagine this is a window? And there's a pressure outside and there's a pressure inside the house, and maybe the pressures are different. Do you think there's a net force on the window? Right. But it's really due to a pressure difference acting over some area, wouldn't it be? So you guys kind of imagine that, right? Right. What else got here? Right, here's another Pascal test. I don't know if there's a YouTube actually on me, but whatever I thought was the best from the book. Right?
Not helping. What are we talking
If you see anything like, do you guys remember gauge pressure can be rho GH, where H is the depth in a fluid, rho GH? Right. No, because how do I take gauge pressure? That's what this is, gauge pressure, just the pressure due to the water. And turn this into an absolute type pressure. Like, what's the absolute pressure down here?
Yeah.
What's the other thing I have to do?
You have to add one
Exactly. Yeah. You have to add 1 atmosphere, also pushing above. Right. So I think rho GH. All those I color coded yellow, so if I show up here, here, and here, these are all in order. In the packet. Let's got. Archimedes. Actually, this one right here, the resulting buoyant force. That's more like Archimedes' principle. And so rho Vg, where V is the displaced volume, rho is the density of surrounding fluid, G is gravity field. So anything that's color coded blue, which looks like there's 3 here, 2 here, so it's like 5 here, and also 3 near the end. Oh, and also 1 in here, kind of near the middle. Okay. You can solve with Archimedes' principle. There's one question I think I remember has like a wood block floating, and there's some percentage of it that's submerged. That's basically that. Okay. Right. Anytime something's floating and some percentage of it's submerged, right, you have to derive it for an FRQ. You can do it. Right. Guys, conservation of flow. So you guys know volume per time is conserved throughout the system. You can break it down to area, like cross-sectional area times linear speed. Right. So that's conserved. A1 equals ATV2. Right. Where's that here? Okay, so kind of this pink color. You guys see this kind of pink color? So these 4 here, this one down here, and these 2 here are related to something to do with flow rate. Right, flow rate. Right? Your textbook asks you a couple questions. It's like, how much time does it take to fill a container with water, right, from a hose? Right, guys, could you guys do flow rate times time equals the amount of volume that's being filled up? Yeah, I think you guys can figure that out just from looking at units, right? Yeah, guys, whenever you see conservation of flow, a good opportunity, a lot of times follow-up question is something about pressure, right, pressure changes. And that's Bernoulli principle. Bernoulli principle, I colored in red. So these 3 in the middle, and this one, well, a little bit closer to the end, gets color coded red. There is actually, let me point to one specifically. Okay. I want to point this out. It's this one right here. Actually, this picture goes to this question out here. Sorry about that. Right. So this question out here says number 6. Right. Here's actually the picture that goes with this. You guys see there's a tank of water. Right. It's like filled to the brim up here. But there's a hole punched 5 centimeters down, and there's some water spraying out, making a projectile path. You guys see that? Okay. Now, guys, what pressure is actually what depth of water actually leads to the pressure that would result in whatever spurt speed? Is it the full 20 centimeters height, or is it just the 5 centimeters height? Yeah, just the 5 centimeters. Right. Everything else doesn't really matter. Okay. One reason I'm pointing this out is that I've seen AP ask pretty much this exact question before as an FRQ. Right? And another reason is, there you go. Okay. So you can start with Bernoulli principle. From Bernoulli principle, you can find leak speed. And you guys know what the answer is going to be. It's going to be square root 2gh at the end of the day. Right. Again, playing off this 5 centimeter height, I think it'll be 0.05 meters, something like that. Okay. Now, guys, after that, if you want to know, say, like, where does this land? Where does this land? Okay. You guys remember taking those projectile launchers a long time ago? Go to the balcony? Okay. Well, I had you guys measure where it landed and back calculate the blast speed. Okay. But this poster's a little bit different. This is saying if you know the blast speed, can you determine where it's going to land? Okay. And that's more like this. So this goes way back in the day. This was the first stuff we did in this class. You guys remember projectiles? Okay. So there's a projectile follow-up on this one. I just want to at least point that out. Okay. I think that's everything. That's everything. Okay. So yeah, these are color coded. I'm gonna leave this up during class. You guys know, of course, during the AP exam, they'll give you this page, all the color coding on it. Right? Here's all your fluids formulas. I just walk you guys through all of them. Okay. So pick any 7. I'm going to recommend maybe picking at least 1 of each color. Right, that would cover all the bases, wouldn't it? Right. And then, I'll walk around and help you guys out. Get ready for the quiz tomorrow.